Welcome back to my YouTube channel. Today we are going to solve this tricky triangular like equation. So here we are given with perpendicular. This is perpendicular, this is base, and this is hypotenuse, and this is a right angle triangle. This is a right angle triangle. Okay, so this is a right angle triangle, so we are going to solve it for n. So we know for right angled triangle, b square plus p square equal to h square, and base square plus perpendicular square equal to hypotenuse square. So let's substitute the values. N square plus n to the power 4 equal to n to the power 6. So this is our final identity or equation. Okay, so to solve this we will take n square as common, then we will get 1 plus n square equal to n square and n to the power 4. So here n will be equal to 0, then only we will get both side equal. So n square equal to 0, which makes no sense as we are solving for a triangle, right? It must have a value greater than 0. Okay, n must have a value greater than 0 because n equal to 0 must not satisfy any triangle. Okay, so we are left with 1 plus n square equal to n to the power 4. This is polynomial. Okay, this is polynomial equation. So good so far. Let's say n square equal to p, we are assuming it, or let's say n square equal to c, because c is not used here, we have already used p here, so we are using n square equal to c. So we will get 1 plus c equal to c square, which means c square minus c minus 1 equal to 0. Just rearrange it. This is polynomial of second degree, polynomial of second degree, same as ax square plus bx plus d equal to 0. This has solutions x equal to minus b plus minus root b square minus 4ad upon 2a. So we will use these things. Okay, here in our equation, if we will compare these both the equations, we have a equal to 1, b equal to minus 1, and d equal to minus 1. So this is very simple to solve. Hence we will have c equal to minus b equal to plus 1 plus minus root b square equal to 1 minus 4 into 1 into a. Okay, so this will be minus d is also minus, right? So a b c d equal to a minus 1. Okay, so this will be b square equal to 1, 4 into 1 dot minus 1 upon 2 dot a equal to 1. So we will have 1 plus minus root 5, okay, upon 2. So we have two values of c, which are 1 plus root 5 by 2 and 1 minus root 5 by 2. Okay, these are the two values of c we get, but we know n square equal to c, so c must be greater than 0. C must be greater than 0, but 1 minus root 5 by 2 is less than 0 because root 5 is greater than 1. So this will make it negative. Okay, we are left with only one value, c equal to 1 plus root 5 by 2. So that means n square equal to 1 plus root 5 by 2. Now n square minus 1 plus root 5 by 2 equal to 0. So which means n square minus 1 plus root 5 by 2 square root square equal to 0. So that is the same thing, because we are going to use that identity, a square minus b square equal to a plus b, a minus b. Okay, we are going to use this identity. That's why we are doing this root and square here. Okay, so we will have n minus root 1 plus root 5 by 2 and n plus 1 plus root 5 by 2. this is whole root equal to 0. Now these values, these brackets must be individually 0 to satisfy the condition. Okay, this must be equal to 0, this must be equal to 0, which means n can be either 1 plus root 5 by 2 whole root, and n can be minus 1 plus root 5 by 2. Okay, but again this is a triangle, this is a triangle, so n must be greater than 0. But what is this? This is negative, less than 0, so this is also not a solution. Hence n must be equal to 1 plus root 5 by 2 whole root. This is our solution, the answer of the question. Thank you.